Modern supply chains are buckling under the sheer velocity of incoming data. When millions of variables flow into a network that relies on manual, human decision-making at its center, the entire system inevitably grinds to a halt. In industrial engineering, trying to fix this by tweaking existing processes is a dead end. The era of marginal optimization is over. Firms are operating with a massive 30% structural price disadvantage. Standard software updates cannot patch a gap this wide. Coupled with a 25% time-to-market gap, traditional firms continuously lag behind competitors. Closing these gaps requires a complete redesign of value streams, driven by AI agents. Traditional digital transformation assumes the existing workflow is correct and simply tries to execute it faster. But the flaw is in the architecture itself. Human processing bandwidth is the bottleneck. Surviving this landscape requires abandoning the illusion that better dashboards will save you. You have to structurally tear down and rebuild the value stream from the ground up. Many industrial enterprises realize this and immediately make a massive strategic error. They try to compete directly with tech giants by building their own foundation models. Foundation models require massive GPU compute, gigantic datasets, and billions in capital, an unwinnable trap for industrial firms. Instead, adopt a leapfrogging strategy focused on the application layer, leveraging existing assets, excellent research, domain knowledge, proprietary data, and engineering heritage to scale industrial physical AI. When you wire these specific, highly contextual assets together, you create specialized AI systems. A generic trillion-parameter model cannot replicate the nuanced proprietary physics or logistics data of a specialized engineering firm. Competitive advantage no longer comes from owning the AI brain itself. It comes from structurally hardwiring that intelligence into the physical and operational reality of your company. Becoming an AI-native firm requires moving past isolated software pilots. You have to install a unified, real-time operating system that connects every department. This flowchart outlines 7 distinct pillars of autonomous value creation. Tied together by Control AI, these platforms operate autonomously in real time, processing data and executing decisions. Sourcing AI acts as the tip of the spear, offering the most direct path to measurable financial impact. Procurement can no longer be viewed as a back-office administrative chore. It is the primary testing ground for validating autonomous corporate strategy at scale. To run this system, look at the organizational chart. The traditional human-centric hierarchy is structurally too slow to process modern supply chain data in real time. The replacement architecture dissolves the top-down tree into a dynamic network of nodes. This creates shared agency, humans and machines jointly orchestrating operations. Purple nodes represent AI agents executing high-volume transactions. The gold nodes alongside them are human orchestrators, elevated to focus on governance, strategy, and ethical decision-making. Modern enterprise performance now relies on this synchronized orchestra, a hybrid of human intelligence and machine capacity working as a single, unified agency. This architecture naturally raises a core executive question. Where exactly does the machine's autonomy end and human liability begin? This diagram strictly defines operational boundaries. The bottom layer houses synthetic roles, AI agents taking on heavy lifting like calculating should costs and drafting contracts. The top layer isolates human roles. Humans act strictly as validators and domain experts, steering strategy. They don't build spreadsheets. The AI does not replace the domain expert. Instead, it acts as a synthetic multiplier. It scales human execution capacity infinitely, while guaranteeing the human retains absolute final decision authority. To see how this architecture performs under pressure, we can examine a recent pilot case inside a mechanical engineering firm suffering from acute supply chain failures. The firm was severely missing its targets. Their rush order rate hit 7.5% against a target of less than 5%. Every rush order incurred a 25 to 40% cost premium, aggressively degrading their F4 financial performance indicator. To dismantle this problem autonomously, the sourcing_AI module relies on a military-derived framework called the OODA-Loop: observe, orient, decide, and act. It begins with Phase 1, observe. The AI continuously monitors raw operational data, Without human prompting, it flagged the 7.5% rush order anomaly and immediately correlated it to the failing F4 financial metric. Next is Phase 2, Orient. The AI contextualizes the data. It looks past the surface symptom, the suppliers charging premiums, and identifies the true root cause: internal, systematic demand planning deficits on the factory floor. The system functions as an active diagnostic intelligence, moving past static visualizations to expose systemic rot without requiring human queries. Diagnosis is only half the battle. The true value of the shared agency model is realized when the system shifts from analysis to execution. In Phase 3, Decide, the AI evaluates potential solutions and prioritizes 3 structural interventions, ranking them from P1 to P3 based on maximum impact and operational speed. Finally, Phase 4, Act. The platform deploys its agents. It autonomously calls the Solve 2026 app to execute immediate data interventions and triggers the TMG 2026 app to establish a predictive, rolling 6-week demand plan. Crucially, it includes a human integration step. The system deploys a third agent, Shula 2026, to instantly generate training modules for the disposition team, ensuring the staff can actually operate alongside the newly established predictive models. This architecture is continuous. The exact moment the Act phase concludes, the system routes directly back to Observe to relentlessly track the efficacy of its own interventions. This module validates the OODA-Loop architecture as a functional building block for autonomous corporate logic. By resolving a high-stakes supply chain failure, it provides the blueprint for scaling this cognitive network across the rest of the organization.